Let's talk about completing the square method. In completing the square method, so let me quickly express it. Completing the square. So I'm going to start by explaining what this word completing the square means. Where does it come from? Why do we call it completing the square? And to explain that, I'm going to use an approach that ancient mathematicians used to solve this kind of problem. Before the era of algebra, mathematicians used geometry to solve a lot of mathematical problems. So I'm going to use geometry to address this and explain why they call it completing the square. So now let's take a look at this example. We have x squared plus 2x minus 15 equals 0. So the first thing we do is to take the constant to the right. So that gives you x squared plus 2x then equal to 15. So what's the next thing? The next thing is I'm going to use geometry to explain how mathematicians picture this. So what they do is they look at this x squared as a square, a literal square. So now the square is made up of x times x. So that's x times x, x squared. Then they imagine this to be 2x. So which is something like this. Imagine this side is x, the same length as this. Then this side is 2. So what they do then is to split this into two equal parts. So which means you have something like this. X on this side and 1. Then you have another part. X on this side and 1. So what they do next is they try to combine this in a very interesting way. So they take this square part, which is x times x. They merge this beside it. So when they merge this beside it, it becomes something like this. It becomes something like this. So this side is x and this side is 1. They just take this and just attach to this. So this is 1, this length is 1, this is x. So the total length here is x plus 1. So that's the total length. Now, the next thing they do is they take this other half, they flip it. So just imagine you take this half, you just rotate it and you stack it here. So in other words, you just attach this here such that this x is here, like this face. You just turn it 90 degrees and then you put it here. Then this side is now here, right? This is 1. This is the 1. From here to here is 1. So that the whole of this is now x plus 1, right? So this is from here to here is x plus 1. From here to here is x plus 1. Because this is x times 1. This is x times x. So now that you've gotten this box, there's something missing. This zone. If we get this zone, we will complete this square. Think about it this way. This is x plus 1. The whole of this. The whole of this is also x plus 1. Assuming we have a complete, we fill this zone. This bigger square will become x plus 1 times x plus 1. So the whole idea of completing the square came from this whole notion that what are we going to get? What should be the dimension of this part that will complete this whole square? So if I ask you what should be the length and breadth of this section that will make this to be a perfect square, that is x plus 1 on this side, x plus 1 on this side. Now it's very easy because if you want this to be a complete square, this is x already. This must have a size of 1 because this is x plus 1 so that it will align with this. Then this must also have a size of 1 because if you have x plus 1 here, you need to fill this 1, this extra 1. Then you also need to fill this extra 1. So it means the square that you must attach to this existing structure to form a bigger square, a bigger perfect square, is a square of 1 times 1. So think about it, 1 times 1. So which means when you look at this equation, you need to multiply, you need to add a square of 1 times 1. So which is 1 squared. Like you need to attach this 1 square to complete this square. And once you add anything here, you are going to do the same thing on this side. 15 plus 1 squared plus 1 raised to power 2. So this whole idea of completing the square method came from the idea that you need to add a particular box to this existing structure to make this a perfect square. And that thing you must add to both sides to make this a perfect square is a square of 1 times 1. And that is how we came about this 1 raised to power 2 and 1 raised to power 2. But if you read typical text, they'll just tell you divide this coefficient by 2 and square it. Well, how did they come about it? They came about it from this geometry. This is how ancient mathematicians used to actually address this issue. So now let's go about solving it this way. So now we've got the number to add to make this a perfect square. Now, if you see this, by attaching this 1 and 1, what do we have now? We now have a square of 1 plus 1 times 1 plus 1. So instead of writing the whole of this whole of this becomes x plus 1 squared, because that's what we got from this big box here. So this is a square of x plus 1. So x plus 1 times x plus 1. So this can be exactly written as this. And now we have this, which is equal to 16. So this is 5 plus 1, 16. So now we proceed to look for the square root of both sides. Now that gives us x plus 1. But then if you take the square root of this, it could be plus or minus 16. So why we in math we use the word plus or minus is this. If you square a number, if for example I have the square root of 4 is either 2 or minus 2. The reason is minus 2 times minus 2 will give me 4. Plus 2 times plus 2 will give me 4. So that's why in math you always use plus minus to show that the answer is either plus 1 or plus 2 or minus 2. So the same thing here. So when you take the square root of the 16, is a plus or minus of that square root of 16. And that means the answer is plus or minus 4. And that's x plus 1. So the next thing I want to do is to solve for x, which is taking each of this. So you can say minus 1 plus or minus 4. So if you simplify, you are going to get something like this. So let me quickly write it here. So that will give you x. Okay, let me just use this space. I don't want to erase this. So that will give us x equals minus 1 plus 4 will give you plus 3. And minus 1 minus 4 will give you minus 5. So these are the possible answers. These are the possible results. So the answer is 3 or minus 5. So this is just a way to explain how we came about this whole term completing the square. We are actually completing a literal square. There's a square we actually want to complete, which is this kind of square. So now let's take a look at another interesting example to make this clear to you. So let's take a look at example 2. So let's take a look at this example. So let's say we have y squared. Then we have minus, let's say this time around we have minus 6y, then plus 5. And let's say this equal to 0. So what's the value of y? And let's say we want to use completing the square method to solve this. I'm going to use that same geometry to illustrate this. And eventually I will give you a standard approach we use without the geometry. So let's look at it this way. So the first thing I will do is to take this 5 to the other side. So that gives you y squared minus 6y equals minus 5, right? So the next thing you want to do is to look for the value of, is to express this as boxes. So you want to say this is y and y. Then the next thing I want to do is to represent the 6 as, I want to represent this as y and this is 6, right? So the next thing I want to do is to divide this into 2. So that becomes something like y on this side, then 3 on this side, then we have y on this side and 3. So let's rearrange all of this. So if you rearrange all of this, you're going to get something like this. Here you have y. Then you attach something like, this is 3y, that's this particular 3y, just stack it here. Then you take this one, you stack it here. Now, when I say stack it here, this becomes you rotate it like this so that this becomes y, then this becomes 3, right? So the question is, what do you need here? What do you need? What is the extra box that you need to fill here to make this a perfect square? Note that we already have y, we already have a y and 3, right? We already have y and 3. But one thing you should note is this. Because of the fact that we have negative number, this is something like minus 6. So it's as if you have minus 3 here. So instead of just plus 6. So you can imagine this to be like minus 3, minus 3. Just imagine that this length is minus 3, right? So if you combine this, you see that this is y minus 3 and this is y minus 3. So that is what the total length here is. And that's what the total length here is. So what should we combine to make this a perfect square? Well, it's very straightforward. Since we have y minus 3, you need to add minus 3 here. Then you also need to add minus 3 here. So that's basically what you need to do. You understand? So now it means what we need to do is we need to add minus 3 square because this minus 3, that's minus 3 to both sides. So this is basically what completing the square is. What square should we attach here that will make this whole square to be a perfect square? So now we have minus 3 squared. So if you add this to both sides, you have y squared minus 6y, then plus minus 3 squared equals minus 5 plus minus 3 squared. So we don't need to simplify this. We don't need to waste our time on this. Just take this square because we know this whole thing will give you y minus 3 squared. That's what we know it will give us. So then, because that's what this box become, that's what we got after attaching this minus 3 times minus 3, so which is minus 3 squared. Then if you simplify this, that gives you minus 5 plus 9, and that will give you y minus 3 squared equals 4. So now let's solve for the value of y. So we can simply solve for the value of y as follows. So we just say y minus 3 equals the square root of 4. But this time around, you have plus or minus because it's either plus or minus square root of 4. Then y minus 3 will be equal to plus or minus 2. And y becomes 3. You take this to this side, 3, which is plus 3, plus or minus 2. And y is either, if you add them, that's 5. If you subtract them, that's 1. So y is either 5 or 1. So that is completing the square method using geometry. Now, let me now formalize it and show you how you get it done without geometry. So you have y minus 6y. Then here you have plus 5 equals 0. Y squared rather. So here you have y squared minus 6y. You take this to this side, that's minus 5. So what you need to do is this. Take this coefficient of y. Take the coefficient of y. Note that this rule applies when the coefficient here is 1. If the coefficient here is not 1, you divide all through by the coefficient of y. So make sure the coefficient here is 1. If it's not 1, just divide all through by the coefficient of y. So now that we have this, just take this minus 6, divide it by 2. That gives you minus 3, right? Then square that value. So this is what you add to both sides. So what that means is whatever you have here, divide by 2 and square it. So when you do that, that will give you minus 3 squared, minus 5, then plus minus 3 squared. And once you've done this, all you need to do next is just to take this y minus whatever you have here, then just square it. That's all. Don't go further, just take this minus 3 because this is just a general rule that emanated from the geometry. So whenever you see people use this formula, the whole thing originated from the geometry, and this will always give you y minus 3 squared, then equal to, then you simplify this as usual, which is minus 5 plus 9, and that will give you 4. Then you have y minus 3 equals the square plus or minus 4, and y becomes minus a plus 3 plus or minus 2. The y is either 5 or 1. So this is the general approach you use without the geometry. So now let's solve one more question. 2x squared minus 3x. Then we have minus 14 equals 0. So what's the value of x? So let's approach it this way. This x squared minus 3x. You take this to this side, that's 14. Since the coefficient of x squared is not 1, you need to divide all through by 2 to ensure the coefficient here is 1. So this becomes x squared minus 3x over 2 equals 7. The next step is to look for what you will add to both sides to make the left side a perfect square. And the rule is simple. Just take minus 3 over 2, divide by 2, right? You divide this by 2, you have minus 3 over 4. Then after you divide by 2, you square it. So that's it. So this becomes x squared minus 3x over 2. Then you add this to both sides. That is, you just say plus minus 3 over 4 square equals 7 plus minus 3 over 4 square. And once you've done this, all you need to do is to just take the square. So x minus 3 over 4. Then you just square it. That's it. Then you simplify this part. So this gives you 7. If you square this, that will give you plus 9 over 16. And if you simplify further, you're going to get, so this gives, if you use LCM, this 16, 1 and 16 is 16, 1 times 7, that will give you 112. Then plus 16, 16 is 1 times 9, that will give you 9. Then this will give you 121 over 16. So the next phase is to take the square root of both sides. So this becomes x minus 3 over 4, which is equal to the square root of 121 over 16. This is plus minus, don't forget that. So what is the square root of, you take the square root of numerator and denominator separately. So what is the square root of 121? That will give you 11, and the square root of 16 will give you 4. Then x becomes 3 over 4 plus or minus 11 over 4. So you just take the plus and minus separately. So you just say 3 over 4 plus 11 over 4, and that will give you, since they have the same denominator, you can add this up. But basically, this is what it is. That will give you 14 over 4, and that will give you 7 over 2. Then for the other possibility, that's 3 over 4 minus 11 over 4, and that will give you minus, that will give you 3 minus 11 over 4, basically. So that will give minus, this will give you minus 8 over 4, and that's minus 2. So x is therefore minus 2 or 7 over 2. So that's the answer using completing the square method. So the next topic we're going to talk about under quadratic is how to use the formula method, which is like the easiest, but it's emanated from completing the square method. So that's the next concept we're going to talk about. Now let's talk about the formula method. So what's the quadratic formula? The quadratic formula is very straightforward. If you have ax squared, this is a general representation of a quadratic equation, plus c equals 0. You can directly get the value of x as follows. The value of x becomes minus b plus or minus the square root of b squared minus 4ac divided by 2a. So this is the quadratic formula. So it's very straightforward. So in the previous example where we had 2x squared minus 3x, then we had something like minus 14 equals 0. We could have just used this formula straight up, and that will give you x equals, so in this case, a is equal to 2, b is equal to minus 3, and c is equal to minus 14. So just plug them in, and that will give you minus bracket minus 3, b is minus 3, then plus minus the square root of b squared, which is minus 3 squared, minus 4 times a is 2, c is minus 14, right? And everything divided by 2 times 2. So let's simplify. So minus times minus will give, that will give you 3. That's plus minus the square root of this will give you 9. Then minus 4 times 2 times minus 14. So first, what is 4 times 2? That will give you 8. Then minus 8 times minus 14. That will give you plus 1, 1, 2. And everything divided by 4. So what that means now is you simplify. So let's continue here. X then becomes 3 plus minus the square root of 121 divided by 4. Then you have 3 plus minus 11 divided by 4. And if you simplify this, you will get 3 plus 11. That will give you 14 over 4, or 3 minus 11, which will give you minus 8 over 4. Therefore, you have 7 over 2, or minus 2. So this is how you use the formula method to solve quadratic. It's the easiest. If you have your calculator, you just punch in the numbers and you have your result. So, but if you have an exam where they specifically told you, a very theory question, where they specifically told you to use a particular method, then you don't have a choice. But if you have the freedom to choose, the formula method is the fastest, basically. You just punch in some numbers, you solve with a calculator, or you just simplify it and you're done. So these are the methods for solving quadratic equation.